Okay guys, this is a trial run of uh, doing a screencast, and hopefully you guys can follow along. If there's issues, of course, you can always ask me to clarify anything, but here we go. This first section is on arithmetic sequences, and it comes from chapter 2, and we're in section C. So a good start is really just defining what an arithmetic sequence is compared to what would be a geometric sequence, which we'll talk about next day. So a good working definition of this is that an arithmetic sequence is a sequence in which each term differs from the previous one by the same fixed number. So let's write down a definition for that. Okay, so this means that whenever you're going to the next term, you're not multiplying, you're not squaring, you're not taking the square root, but instead you're really just adding or subtracting to get the next term. Let's take a look at an example. So if you took a look at the sequence 2, 5, 8, 11, and 14, most of you guys could predict what the next term would be. But the reason this is an arithmetic sequence is that each term actually differs by the same number. So what exactly is that difference? What is that number that separates each term? Well, if we take a look at it, we could say that the difference between 2 and 5, or 5 take away 2, is 3. So is 3 that number? Well, take a look at the next term. We could say that 5 and 8, the difference is 8 take away 5, which equals 3 as well. And then you could say the same thing with 8 take away, or 11 take away 8. That would also give us 3. And of course 14 take away 11 is also 3. So it is arithmetic because there is the same difference between each term. That of course is the definition by words, but what would be the definition if we're looking at it algebraically? So in an algebraic definition, you would actually get something that looks like this. So here you see that the sequence would actually be a term, or a arithmetic sequence, sorry, if the term was differing by the same amount. So you see that un plus 1, that would be like your term that comes after the term you're talking about. So if I was talking about term number 3, I would say, well, term number 4 minus term number 3 would equal d. So in this case, d has to be a constant. It's that same difference that you see throughout all of your terms. Okay, so think about this. If we made a statement like a, b, and c are consecutive terms of a sequence, and b minus a equaled the same thing as c minus b, could you prove that this was in fact an arithmetic sequence? Press pause and think about that for a second. Okay, to really solve it, you need to think about what this statement is actually saying. B minus A equals C minus B. What we're really saying is this, that the difference between the second and first term is actually the same as the difference between the third and second term, meaning that D is in fact a constant. In fact, if you wanted to, you can actually solve for B, which is the middle term. So if I rearrange the formula a little bit, I could say that since b minus a equals c minus b, then b plus b should equal c plus a. In fact, you could say 2b equals a plus c. I've just rearranged it. Now take that one step further. I'd say that b equals a, in fact in brackets a plus c divided by 2. Now what that actually is saying is that if you add up the two n terms and divide it by 2, in other words, you find the average of the first and third term, you will find the mean, or the arithmetic average of the terms on each side. Not surprisingly, b is the average of the two numbers on either side. To take that one step further, you can consider the question, or the sequence 1, 2, 3. Now we know, of course, that this sequence